Welcome back to my YouTube channel. So today we are going to solve day 10 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today we are going to solve problem number 962, maximum width ramp. So let's read the problem statement first. A ramp is an integer array nums is a pair I comma j. Okay, so let's treat them as indexes for which I is less than j and nums of I is less than equal to nums of j. The width of such a ramp is j minus I. So we have given an integer array nums and we have to return the maximum width of a ramp in nums. If there is no ramp in nums, then we have to return 0. Okay, so here see the example number 1, and this is my nums array. Okay, so let's first give the indexes 0 1 2 3 4 5. Okay, so now let's say my I is at index number 1 and my j is at index number 5. Okay, so here first thing I is less than j. Okay, so this condition is satisfied, right? And nums of I, here value at nums of I is 0, is should be less than or equal to my nums of j. So here 5. So this condition is also satisfied. Okay, so now let's calculate the width of such a ramp. So width of such a ramp is j. J is nothing but 5 index and I is index 1. Okay, so what is the width that I'm getting? I'm getting 4. Okay, so that is why output is 4 for this particular example number 1, right? So I hope that you guys are clear how we are getting this output. Okay, and same way for this example number 2, just give the indexing here 0 1 2 3 4 5 6 7 8 and 9. Okay, now let's say my I is at index number 1, at index number 2. Okay, let's say index number 2 and my j is at index 9. Okay, so again see all the conditions are satisfied now. I is less than j, condition number 1 satisfied. Nums of I, that here value is 1, is less than equal to nums of j, value is 1. Okay, so this condition is also satisfied. So that is why j minus I, the length of ramp is, width of this ramp is 9 minus 2 is 7. Okay, so that is why we are getting 7. So now we will see how we are going to achieve this. Okay, so there is one way. Let's say this is my input. Okay, 608215. Okay, 608, then 2, then 1, then 5. Okay, so one way to achieve this is to calculate, just go iterate over all the elements in my nums array one by one. So let's say initially my I is at this position. Okay, then for this element I will initiate one more loop for my j. Okay, so I am going to get started from my j value from here. Okay, so for this value, okay, for this value I will try to find the value where my nums of I, okay, nums of I is less than equal to nums of j, nums of j. Okay, so here nums of I value is 6 and 6 is less than equal to 5. No. Okay, so what I will do, then I will just decrement my j to the next position. Okay, so now let's say my j is moving to this position. Okay, so now here nums of I is 6 and 6 is less than equal to this 1. Okay, no, it is not true, right? So now again my j is decremented. Okay, so now my j is moving to this position. Again it will fail. Okay, there is nothing. Now my j is going to decrement to this position. Okay, so now here in this case this condition is satisfied, right? My nums of I is less than equal to, nums of I is less than equal to nums of j. Okay, so this condition is satisfied. Okay, so now here, now calculate the width of this ramp j minus I. Okay, so if I just give the index in here 0 1 2 3 4 5. Okay, so here 2 minus 0, 2, 2 is the length, right? So now 4 6. Okay, when I was when my I was fixed in 6. Okay, when my I was fixed at element 6, that is nothing but index 0. Okay, index 0. 6, then I get the width as 2. Okay, now for the next step, just move my eye to the next position. Okay, so now let's say my eye is moved to this position and my j is again starting from here. So here again check this. So this condition is always satisfied. Okay, I'm checking like this only, I is less than j. Okay, I'm making sure that this is always true, and then after that inside this I'm checking this. So nums of I 0 is less than equal to nums of j. J is 5. Okay, 5. Okay, this is true. Okay, 0 is less than equal to 5. So what is the width here? J minus I, 5 minus 1, 4, and this 4 is greater than my previous width which we got last time. Yes, so update my max width to 4. Okay, so and break it. Okay, and we don't need to decrement j further, right? Because this is going to be max width. Okay, if it is attainable here, then we are good. Okay, then after that move my I to the next position and again start j from here, and then again try to calculate the width that we can achieve here. Then again j is going to, okay, 8 is less than equal to 5, no. So again j is going to move further. Here again j is going to move back. Okay, 8 is less than equal to 2, no. So now we will stop here, we will not get anything here. Okay, now next time again move my I to the next position. Okay, again I is starting from here, j is starting from here. Okay, so this is one approach, and with this approach I have solved this problem. So see, 100 test cases got passed out of 101, because time complexity is going to be of n square now, right? I am running this for n times. Okay, then again inside this I am running this for n times. Okay, while my I is less than equal to j. Okay, so that is why the time complexity is going to be of n square. So now let's see how we are going to solve that. So for that purpose I am going to use monotonic stacks. I will create one monotonic decreasing stack. Okay, in which I am going to store the elements in decreasing order. Okay, like this. So here if you just take this example, 608215. Okay, 608215, right? So this is 608215, and so see here, so 6, I'm going to insert this 6 in my stack. Okay, stack is empty, so insert it. Then after that 0 is smaller than 6. Okay, let's insert that. 8, 8 is smaller than this 0, no, we are not going to add this. Okay, we are not going to add this. Then 2 is less than 0, no, we are not going to add this. 1 is less than 0, we are not going to add this. 5 is less than 0, we are not going to add this. Okay, so this is done. So in the my stack I have added these two elements only, that's it. Okay, this is done. Then after that I am going to iterate from reverse direction. Okay, so here let's say 0 index, 1 index, 2 index, 3 index, 4 index, and 5 index. Okay, so now my j loop is going to start from here. Okay, I will start iterating from here. So for this element, okay, I will check for this particular element I will run one while loop, and in this, inside this while loop I will check if my stack is not empty. So my stack is not empty, and then after that I will check if the peak. Okay, so here instead of 60 I will just add the indexes. I will just add the indexes. So 6 is at 0 index, and this 0 is at 1 index. Okay, so this is what I'm going to add. Okay, so this is just for reference. Okay, 0, so ignore it, we are not going to add, this 0 in stack and this 6 in stack, but we are adding indexes. Okay, 1 index and 0 index. Okay, so now what I'm going to see here, I will check if my stack is not empty, and nums of okay, nums of stack dot peak. So at peak index is 0. Okay, less than equal to nums of j. So j is 5. Okay, so let's see, nums of 0 is nums of 0 is at 1 index. Now here I'm passing index, so here it is should be 1 now. So at nums of 1 we have 0, and at nums of 5 we have 5. So this is true. Okay, if this is true, then update my width. So I am going to update my width as this j is nothing but 5 minus stack dot pop. So at the top of stack, what I'm storing these indexes only, right? So let me just remove this. From here we will just get this index. So 5 minus 1 is 4. Okay, so I will update this. We have just popped this element from top, right? And then after that, for my j is going to decrement to this position. Okay, at this position element is 1, right? And I will compare this one with this element 6. Okay, so this is not right. 1 is not, this 6 is not less than equal to this one, right? So my j is going to move further. 6 is not less than equal to, then my j is going to move further. So here I will check one case, 6 and 8. Okay, so 6 and 8, so I will pop this element and width I will get 2, but I don't need to update that width, right? Because this is the max width. Okay, so I'm going to store the max width. Okay, so that's it. And then after that my stack is going to become empty. So that's it. Okay, so now let's see how we are going to write code. Okay, with code you will get better understanding. Okay, so here first thing, let's calculate the length of my nums array. Int n is equal to nums dot length, and then after that create one stack of integers. Stack integer stack is equal to new stack. Okay, then after that we have to build a decreasing stack of indices. Okay, so just run one loop and we are going to iterate from start, right? Int I is equal to 0, I is less than n, I plus plus. Okay, and inside this we are just going to check if my stack is empty. Okay, if my stack is empty, or we have to check few more things. If element at top of stack, in the stack you know that we are just going to push indexes only. So here I'm just what I'm going to write, if nums of top element, okay, stack dot peak. Okay, if this element which is at top of stack, okay, if it is greater than, right, my current element that I want to push. Okay, so if this is true, then in that case we have to just push that element in my stack. Okay, not element, index only. So here that is why I'm going to write I. Okay, that's it. So now once this is done, then here after this let's create one variable int max width. Okay, to store the max width. Okay, and then we have to traverse from right to left to find the maximum width ramp. Okay, so here run one loop for int j is equal to n minus 1, and then j should be greater than equal to 0 and j minus minus, right? And here what I'm going to do, here I'm just inside this, I'm just going to run one while loop while my stack is not empty. Stack is not empty. Okay, and here after that I'm just going to check if nums of stack dot peak element, right, if it is less than equal to nums of j. Okay, so this is the only condition, right? So that we find the ramp width, right? Our nums of I should be less than equal to nums of j. That's what I'm doing here, right? And now after that I have to update my max width is equal to math dot max of my max width, and then after that here j minus, now I need the index from top. Okay, so stack dot pop. Okay, let's remove that top element completely. Okay, since we have used it. Okay, now in the end just return max width. That's it. Okay, so now let's run the code and see if there are any code issues. So for this my time complexity is going to be O of n. Okay, so all the test cases has been accepted, right? So my time complexity is going to be O of n. Let me just format it. Okay, let me first submit it. So see, our solution is accepted, right? And the time complexity is O of n. Okay, and the reason is we are iterating over all the elements here just one time, right? O of n, because I'm just only pushing the elements if it is at top of stack. It is if it is monotonic decreasing, right? So this, if these conditions are satisfied, only then I'm pushing, but I'm iterating over all the elements, right? So O of n, then here we are iterating in the reverse direction, right? And inside this I'm checking while my stack is not empty, and then only I'm checking this condition. Okay, and then I'm updating, and side by side I'm also removing the topmost element. Okay, if I'm using that, so it is also going to take O of n in general, right? So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.